Hello everyone, today is day 70 of solving a LeetCode problem every day, and today I'm going to solve construct binary tree from preorder and inorder traversal. So first of all, a preorder traversal is when we process things in a root left-right fashion. So in this case, we're going to have 3, 9, 20, 15, 7, and then in order, we're going to be processing things in a left root right fashion. So we're going to have 9, 3, 15, 20, and then 7. If you don't know if you don't really get what preorder or in-order traversal, I'd recommend looking into it before solving this question. So we're going to be given two arrays. One's going to be the preorder traversal and one's going to be the in-order traversal of some hypothetical binary tree. The goal of this question is that we need to construct a method which can build this binary tree for us. So one thing that we want to note is the fact that the first value in this preorder array is always going to be the root node of the tree. The reason why is we always start out with processing the root in a preorder traversal. And what we can do is if we look for this 3 in the in-order traversal, we find out that everything to the left of this 3 is going to be the left subtree, and everything to the right of this 3 is going to be the right subtree. And the reason why is that this 3 is in an in-order traversal, this 3 is never going to get processed until the whole left subtree is processed. So basically, if we use these two traversals together, we can kind of we can keep, shortening these arrays. So let me restate that. So this is pretty much what we're going to do. We know that 3 is the root, so we can start out with that. And then we're going to find where the 3 is in the in-order traversal. Now we know that everything to the left of this 3 is going to be the left subtree. So what we're going to do is we see that there's only one value here to the left. So we can just assign 9 to be the left child of 3. But now we see we have 3 values here, the 15, 20, and 7 in the right subtree. So what we're going to do is we're going to shorten this array. We can just pass the 15, 20, and 7 to the right side. And then here, we're going to pass the 20, 15, and 7 to the right side. And what we see now is that with this shortened array, 20 is the first value in the preorder traversal. What this means is that 20 is going to be the root of the subtree. And then we find the 20 here, and we see that there's 15 to the left and 7 to the right, which means 15 is going to be the left child and 7 is going to be the right child. So, that's going to be the general process of how I'm going to solve this question, but let's actually write some code out now. So the base case is going to be if the preorder or the in-order array is empty, we can just return none since that's the base case. Next, we're not going to grab the root. We're going to create the root by just creating a new tree node, since that's what the class is called. And then this takes a value, and for the value, we're going to pass in preorder 0, since that's the root value. Then we're going to find the midpoint, and then all the midpoint is where, so in the in-order array, where I guess the array breaks into left and right subtree. So that's just going to be inorder.index of preorder 0. And another thing to note is that here in the constraints, it says that preorder and in-order consist of unique values, meaning that we're never going to encounter a problem where there's duplicate values in either of these arrays. So another thing to note is that this method right here is going to work in linear time. So next we can do the whole assigning to the left and right subtree. So we're going to recursively call the method again. And this method is going to take a preorder and in-order list. So for preorder, what do we want to do? So if we look at this, for example, so let's say we process this 3, what do we want to pass to the left side from the preorder list? So we know that we want to pass in everything up till that midpoint except the first value, since we don't care about that anymore. We already processed it. So we can just say preorder, and then we start at 1 since we don't care about that value anymore. And then we say mid plus 1 since this second part is not inclusive. And then the second question is what part of the in-order array do we want to pass in? And since we're doing the left subtree, our midpoint is here at 3. So we want to pass in everything until that midpoint. So we can just do it like that. And then for root.right, we're going to do something really similar. So we ask ourselves again, what part of this array do we want to pass in? Our midpoint is 9. We want to pass in everything after that 9. So we're going to say preorder mid plus 1, since we don't want to pass in that midpoint because that's going to be in the left subtree. We want to pass in just this 20, 15, and 7. So we're going to do mid plus 1 until the very end. Now the same thing with Inorder. What do we want to pass in for the Inorder array? So we see here that the midpoint is right here. So what we're going to pass in is just mid plus 1 until the very end. And then we can just return root. So pretty much what this is going to do is, when we assign this root.left or root.right, we know that the root is going to be the very first element in this preorder array. So basically what happens is that root gets assigned, and then we again recursively call the method. Or it happens backwards of how I said it, but that's the general idea. So yeah, so if I run this, seems like I'm getting a network error. Let me reload this page. Cool. Run. Okay. Yeah, I'm not sure what's going on with the site. I guess let me try that. Yeah, I don't know what's going on right now. But anyways, this is a solution. And now we're going to talk about time complexity and space complexity. As for time complexity, the time complexity is going to be O of n squared. The reason why is that we have to process each one of these I guess preorder and inorder. So we have to process every single node in the tree, but we're also finding the index over here, and that can take up to like n operations. So we have n times n, which is n squared. Then as for space complexity, let's see. So first of all, this is going to be a recursive method, and in this recursive method, we're gonna have n elements. And within these n elements, so in the call stack itself, there's gonna pretty much be like n things that we have to do. But then also we have these preorder and inorder lists that is gonna be of length n. So the space complexity is also going to be n squared. So yeah, that's my solution for the day.